In this video tutorial, we were looking at exponential functions, specifically writing, graphing, and evaluating them. So, exponential functions represent a relationship that increases or decreases at a common rate or factor. Each time you increase the input value by 1, the output of the previous input is multiplied by the same factor. The format of the parent function is f of x equal to b to the x power, where b is greater than 0 and b is not equal to 1. The table of the parent function, f of x equal to 2 to the x power, is what we're going to show. If we pick x values, and then we have f of x, which is 2 to the x, and I pick x values of -2, -1, 0, 1, 2, and 3. When I plug them into 2 to the x, 2 to the -2 is 1/4, 2 to the -1 is 1/2, 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4, 2 to the third is 8. So if we graph, we'll come close. We have at -2, we have a quarter, over here on the line, and at -1 we have a half, and then at 0 we have 1, and at 1 we have 2, and at 2 we have 4, and at 3 we have 8 over here. So when we graph it, it kind of skims along the x-axis and goes up. Notice that the output values increase by the same factor of 2 in both the table and the graph. Let's take a look at the domain is all real numbers because we can pick any x value, and the range is y greater than 0 because we never cross the x-axis. Notice as the x value decreases, the graph of the function gets closer and closer to the x-axis. The function never reaches the x-axis because the value of 2 to the x cannot be 0. In this case, the x-axis is an asymptote. An asymptote is a line that a graphed function approaches as the value of x gets very large or very small. Let's take a look at the first example. Before we graph, let's take a look at a couple things. Let's identify the base. Well, the base is what's raised to the exponent, so that is 0.5. We know that the domain for this exponential is all real numbers. because we can pick any x we want. And the range, since we're not adding anything here at the end, we know that the range has to be greater than 0. And the asymptote is the line, so y equals 0. That's what it approaches but never touches. That's why the range is not equal to 0. And the y-intercept, if I plug in 0 for x, and 0.5 to the 0 is 1, so the y-intercept, if there's nothing added to the end, is just 40. So that would be the point 040. If we were going to graph the function, then we can put in a -2, -1, 0, 1, 2 for max values. And then I could go ahead and evaluate that. If we plug in -2, we would have 40 times 1/2 to the -2. And it'd be 40 times 1/2 squared is 1/4. If we take the reciprocal of 1/4 because it's -2, that would be times 4, which would be 160. So this would be 160. If we had 40 times 1/2 to the -1, 1/2 to the -1 is flipped over, which is 2. 2 times 40 is 80. 40 times 0.5 to the 0. 0.5 to the 0 is 1 times 40 is 40. 40 times 1/2 to the first. 1/2 to the first is 1/2. 1/2 of 40 is 20. And if we have 40 times 0.5 squared, 1/2 squared is 1/4. 1/4 of 40 is 10. Okay, so let's go 1, 2, 3, 4, 5. Let's make this -1, this -2. This is +1. Over here is +2. And then we're going to go by 10, 20. So 20, 40, 60, 80, 100, 120, 140, 160. So starting off with -2, 160, -1, 80, 0 is 40, 1 is 20, and 2 is 10. And we see that this is exponential decay. Go ahead and pause the video and try example number 2. Check and see if you have the same answer. If you do, great. Otherwise, check and see how you get it wrong. And then go ahead and do number 3 to be ready for tomorrow.